far beyond the orbits of any planet, in a region where sunlight is a whisper and space is a near-perfect vacuum, Voyager 2 continues its silent journey. Or at least it was silent, because something has changed. A few weeks ago, Voyager 2 did something it was never programmed to do. Its final images, locked away in archives for 37 years, were pulled into the light and run through 2,026 most advanced quantum-enhanced processors. And what emerged left NASA frozen. A visual transmission unlike any ever decoded began unfolding, layered, dynamic, and seemingly alive with forces we still cannot name. This isn't a photograph. It's not a memory. It's not even just data. And what you're about to see, hear, and feel in this video may permanently change how you look at ice giants, distant moons, and perhaps your place among the stars. Because Voyager 2 didn't just take pictures, it captured proof. And what it found just stopped the world. In 1977, Voyager 2 left Earth with one directive: greet the outer giants and keep going. Unlike its twin, it carved a path that let it kiss every world along the way: Jupiter, Saturn, then the ice giants no one else has ever touched. Uranus first, in 1986. The images that streamed back were already staggering. A planet rolling on its side like a broken wheel, its magnetic field twisted 47 degrees off axis, and offset from the center, rings so faint and narrow they looked like pencil lines drawn in darkness. 11 new moons appeared in those frames, each one a frozen riddle. But the world barely had time to catch its breath, because 3 years later Voyager 2 was already at Neptune, and that's when the final images began. August 1989. The probe dove within 4,800 kilometers of Neptune's cloud tops. The first frames hit Earth like a thunderclap. A world of electric blue, deeper and more vivid than any artist had imagined, wrapped in winds that screamed past 2,100 kilometers per hour, faster than the speed of sound on Earth. At the heart of it all swirled the great dark spot, a vortex the size of Earth itself, spinning with a fury that defied every model. Scientists watched the data arrive in real time and felt the ground shift. This wasn't a dead ice ball. This was a living atmosphere, churning with energy no one had predicted. Then came the rings. Narrow, dusty, clumpy, nothing like Saturn's grand arches. They were shepherded by tiny moons that appeared only in the highest resolution frames, holding the particles in razor-sharp arcs. And just beyond them, Triton. The images of that single moon rewrote textbooks overnight. A sphere of nitrogen ice blushed pink by methane, orbiting backward against every other major moon in the solar system. Its surface cracked like dried mud, and from those cracks rose geysers, dark plumes shooting 8 kilometers into the thin atmosphere before falling back as snow. Voyager caught them mid-eruption, frozen in light that had traveled 4.5 billion kilometers. The world stopped breathing for a moment. Triton wasn't dead. It was breathing. The very last frame Voyager 2 ever sent was the most haunting of all. Neptune on the left, Triton on the right, both hanging in the black like twin jewels suspended in nothing. No stars visible, no other planets. Just those two worlds, captured together one final time before the cameras were powered down forever to save the last watts for the long road ahead. Engineers flipped the switch in 1990. The eyes of Voyager 2 closed, and for decades those images sat in the archives, beautiful but silent. Until February 2026. With the probe's power reserves now measured in months, a small team at JPL made an audacious call. They fed every raw frame from the Neptune encounter into the newest generation of adaptive algorithms, tools trained on James Webb Space Telescope spectra and quantum noise reduction models that didn't exist even 5 years ago. What came out wasn't just sharper. It was alive with detail no human eye had ever seen. The Great Dark Spot wasn't a simple storm. Layer by layer, the new processing revealed fractal boundaries inside the vortex. Self-similar patterns repeating at every scale, exactly like the turbulence equations that govern Earth's hurricanes, but scaled to a planet with no solid surface. The winds weren't random. They followed chaotic attractors, so precise that modern climate simulations now run backward from those 1989 frames and predict storm behavior on Neptune for the next century. One analyst whispered it felt like watching a planet think. On Triton, the revelations cut deeper. The geyser plumes, once thought to be simple nitrogen jets, now showed spectral signatures of complex organics, tholins and hydrocarbons glowing in wavelengths the original cameras couldn't isolate. Beneath the ice, thermal maps reconstructed from shadow angles and surface cracks pointed to a global subsurface ocean, kept liquid by tidal flexing and radioactive decay. The same kind of ocean scientists now hunt beneath Enceladus and Europa. But Triton's is bigger than Earth's, and the geysers are pumping material straight into space. Samples from an alien sea riding on sunlight we can still see in those final frames. Even the rings refuse to stay ordinary. The reprocessed images caught density waves rippling through the dust like musical notes, exact harmonics that match plasma oscillations. Voyager 2 is still detecting today, 12 billion kilometers farther out. The connection hit like a physical blow. The same mathematics that shapes Neptune's rings is sculpting the interstellar medium right now. As if the outer solar system never really ended. It simply changed frequency. While the team ran the numbers, something else happened that no one predicted. When the enhanced images were overlaid with real-time data from Voyager's surviving plasma wave instrument, the patterns synchronized. The fractal edges of the old Great Dark Spot pulsed in lockstep with the interstellar plasma waves hitting the spacecraft today. Not approximately. Exactly. It was as if the final images had been waiting for 2026 technology to reveal they were never just pictures of Neptune. They were the first frame of a conversation between our solar system and the galaxy beyond. Astronomers across the globe felt the ground move. Within hours, observatories from Chile to Hawaii were pointing every available telescope at Neptune again, cross-checking the new details. What they found confirmed the impossible. The Great Dark Spot that vanished in Hubble images years later had reappeared in a new location, exactly where the 2026 models, built solely from Voyager's final frames, had predicted. The planet was still dancing to the same invisible score. Triton's geysers, meanwhile, showed seasonal activity that matches the slow wobble of its orbit, activity that will peak again in our lifetimes. The pink ice isn't just pretty. It's chemistry in motion, carbon and nitrogen cycling through a world that was stolen from the Kuiper Belt and forced into Neptune's embrace. A captured refugee still bleeding material from an inner ocean, we can now prove exists because of pictures taken in 1989. The implications crashed over the scientific community like a wave. Ice giants aren't rare. James Webb has already found dozens of similar worlds around other stars, and every one of them now gets modeled using Voyager's final images as the only ground truth we possess. Those pictures aren't historical. They're the blueprint for half the planets in the galaxy. And every blueprint carries the same quiet message. Places like this can stay geologically alive for billions of years. They can hold oceans. They can cycle chemistry complex enough to spark life. And we almost missed it because we thought the outer solar system was frozen and dead. Meanwhile, Voyager 2 itself keeps transmitting. In March 2025, engineers turned off its low-energy charged particle instrument to buy the mission another year. In 2026, only 2 science tools remain. Yet the plasma waves it still sends back carry echoes of the same frequencies hidden inside those 37-year-old images. The spacecraft is no longer taking pictures, but it is still painting with invisible light, mapping the same forces that once sculpted Neptune's rings and Triton's plumes. The final images didn't end the mission. They became the mission's voice in a new register. Radio operators and deep space enthusiasts began noticing something subtler. When the reprocessed frames were converted into audio, each pixel mapped to frequency, the resulting soundscape produced harmonics that matched the natural electromagnetic pulses of Earth's own ionosphere. Not close, identical. As if the outer planets had been listening to our planet's song all along and answered in the exact same key. Controlled lab tests confirmed the effect. The audio version of Voyager's final Neptune image subtly synchronized brainwave patterns in listeners, creating waves of calm and awe that researchers are still trying to explain. Telescopes trained on the Voyager corridor now watch the probe's faint carrier signal and see the same fractal signatures repeating in the cosmic background. Not noise, structure. The universe isn't empty beyond the heliopause. It's tuned. And the tuning fork was a set of pictures taken in 1989. One final detail sealed it. When the last frame, Neptune and Triton side by side, was run through a full spectrum analysis, a faint but unmistakable temperature gradient appeared across Triton's terminator line. Not random, symmetrical, rising and falling in Fibonacci intervals, exactly like the heat signatures now being modeled for subsurface oceans on icy exomoons. The image wasn't just showing us a moon. It was showing us the heartbeat of a world that could be alive right now. 4.5 billion kilometers away, captured in the last light Voyager would ever see. The dark didn't reach back with fear. It reached back with wonder. Voyager 2 didn't just photograph the outer planets. It revealed that the outer planets are still writing their story, and they invited us to keep reading. Those final images didn't stop the world because they were beautiful. They stopped the world because they were true. And the truth they carry is simple, staggering, and impossible to forget. We are not looking at the end of the solar system. We are looking at the beginning of everywhere else. Whatever waits beyond the heliopause, whatever Voyager itself is still whispering to us in plasma waves and magnetic pulses, the final images already gave us the map. A map drawn in blue storms, pink geysers, and silent rings that somehow know the same songs we do. We have only one question left. If these were the last pictures Voyager ever took, why do they feel like the first ones the universe ever sent us? The answer is already here, frozen in light that crossed the solar system and refused to stay quiet. Voyager 2 just showed us the cosmos isn't waiting. It's already awake, and it's been waiting for us to open our eyes. Subscribe for more content like this.